Hello, everyone. My name is Alamin, and today we are continuing the assignments from last week. This is regression part two. We are going to be using the same data set, which is the elementary API for 400 schools in the state of California. The first question is asking me to predict the API for the year 2000 using two predictors this time, year round and some call, which basically means the percent of students whose parents have had some college education. We're also being asked to look at the intercept between those two predictors. First, we're being asked to create a correlation matrix with some visualizations. So if we go to JASP, we put our data set, and then we start our analysis. We go to correlation. We add our variables, the API for the year 2000, year-round, and some college. And we start by looking at the raw values over here in the top. We can see the Pearson's R value for year-round is negative 0.475, which is a pretty significant R value. But the negative signs means that it is negatively affecting our API. For some college, we have a lower R value, but it's still pretty significant. As we can see, it's flagged here. I turned on this flag significant correlations, and we can see that both of these values are pretty significant. But some college seems to be positively affecting our API. Some of the plots here, we can see year-round, the values of the API if the year round is zero, basically meaning that there is no summer school. We can see them on average being higher. And if we have a summer school, we can see the API is dropping. If we look at some college for the parents, this is telling us that the API is being somewhat increasing with more students having parents with college degrees. The second part of the question is we're being asked to create some flex plot, and I added the dependent variable is the API, independent variable as my some college, and then the panel variable is year round. And we have two flex plot, one for the year round school with basically one for no summer school and one for summer school. And they both are showing that college education for the parents is increasing that API for both cases, but it has a higher, let's say, effect if the year is open for summer school. The last part of that question is to use regression analysis. And same thing, I use the API as a dependent variable. My covariance is going to be some college, and my factor is going to be year round. The way I divided these models is model zero is basically the API compared to itself, so we can ignore model zero. Model one is has the year round included. Model two has year round and some college education included. And then model three has the intercept between some college and year round. So we can see the R values being reported here for each model and the R squared value as well, which can be a prediction of the accuracy of each model. So R squared for the first model has a value of 0.226. If we add some college to the next model, we can see the R2 increases a little bit. And then my last module, module 3, which has the intercept, has the highest R squared. And we can see the change of an R squared being represented over here in this column. So basically, the more predictors we add, we increase the module accuracy in predicting the API. So model 3 is the model we want to follow to predict the API. Looking at some values here, we can see for model 0, we have a mean API of 647. When we include the first intercept, or basically first predictor year round, we can see that if the school is open for summer, the API is going to decrease by 160 points. When we include some college, we can see this has a positive increase on the API, basically with 1% of parents going to college. The API is expected to rise by 2.2. And then my last module here, where I have the intercept between year round and some college, we can see the API increase by approximately 6. So what this is telling me, if a school is open year round and with every 1% increase in some college, we can expect the API to increase by 6. We also have a residual versus predictor plot, which is showing us the distribution of the residuals. We can see that they are equally distributed. We also have a QQ plot. I would love to see these outliers fall within the theoretical line over here, but this is still a very significant plot. The second question, we are now being asked to see a high number of predictors and see how they affect our API. So first is asking me to create a correlation matrix and then using stepwise to determine the best set of predictors among all these predictors. So we start our correlation by adding API and all the mentioned below predictors. And this is going to create this correlation matrix. And we are concerned with API here, so we can see that year round is negatively affecting our API, very significant R value. We can see that ELL, I believe, is the percent of students who are attending English classes. So basically, percent of students whose first language is not English. Also a high correlation between this and the API, also affecting it negatively. Meals has the highest correlation value of 0.9. Meals is basically the number of students receiving free meals. These are all are negatively affecting API. If we look at the some positive correlation towards API, we can see that some college has a R value of 0.26. College grad, so parents with a graduate degree or who attended graduate schools, has a higher correlation to API. Parents whose students with parents who actually attained a graduate degree has a positive effect to API. Also, the number of teachers with full credentials has a positive correlation to the API. So we can look at this correlation matrix. It also tells us the correlation between the predictors themselves. So if we look at meals and we compare that to not high school, which is the percent of parents who did not finish a high school degree, we can see that those two meals and not high school have a correlation of 0.6. But for our purposes, we're only trying to figure out the predictors in correlation with the API. So if we start our stepwise linear regression, and we can see that it automatically gave me 6 modules. And if I want to take a deeper look at each model, we can see that model 1 incorporated meals, model 2 incorporated meals and EMER, all the way to model 6 that incorporated 6 predictors: meals, EMER, ELL, grad scholar, not going to high school, and enroll. Before I continue with my analysis, I want to mention that in my method specification, I only asked JASP to use predictors with a p-value higher than 5%, meaning they have a significant p-value which means they have some kind of correlation. So any predictor with a value of P being lower than the 5% were not added here in the modules. And then module 6 can predict the six, highly, let's say, influential predictors when it comes to predicting the API. And we can see that Neil have the highest value between them. So when we go back to the question, is used when we are asked to use stepwise to determine the best set of predictors, we can say that those six are the best set of predictors and predicting the API, with Niels holding the most significant value. Thank you so much for listening in. I hope this little presentation helped answering the questions for this assignment. Thank you.